Okay, in this lesson we're gonna learn about a new type of function called exponential functions. So the exponential functions have the x variable or the input as their exponents. So these are the examples. Notice that x's are all the exponents. So you might think that these are kind of similar to the polynomial function, but actually it's not. That's the square function that we are more familiar with. This one has x as our base, whereas that one has x as our exponent. So these are the new type of functions. So to figure out the basic characteristics of this function, let's graph the first function, which is y equals to 2 to the x, by completing the table. If I plug in 0 to x, 2 to the 0 power is 1, because any number to the 0 power is 1. If I plug in 1, 2 to the first power is 2, plug in 2, 2 to the second power is 4, 2 to the third power is 8. Now if I plug in negative 1, 2 to the negative 1 power is 1 over 2, 2 to the negative 2 power, because of the negative sign, it would be 1 over 2 to the second power, which is 1 over 4. 2 to the negative third power will be 1 over 2 to the third, which is 8. So if I plot these points, I'll have a graph 0, 1, 1, 2, 2, 4, 3, 8, and negative 1, 1 half, which is 0.5, negative 2, 1 over 4, negative 3, 1 over 8. So the graph increases pretty steep. If I plug in like 4, I would get 16, so that's pretty high up there. Notice that if I plug in like negative 4, I will get 1 over 16. If I plug in negative 5, I will get 1 over 32. If I plug in 1 over negative 6, I will get 1 over 64, and so on. So it tells us that even if I plug in really small negative number, or like large absolute value, I will never get 0 as our y value. You're gonna get tiny little fraction as a result, but you're never gonna reach 0. That's why the red graph approaches to this x-axis, but it's never gonna touch that line. So this line that the graph approaches to but never touches it, we call it asymptote. So that's a new vocabulary. In our case, the asymptote would be that line which is the x-axis, or it will be the line of y equals to 0. So that's our asymptote. If you look at the domain left and right, it goes forever to the left and right, so the domain will be all real number. Range, the y values are all the values above 0, so y will be greater than 0. Y can never equal to 0 because y value does not equal to 0 at all. Exponential, because this graph increases, we call it exponential growth. Let's take a look at the next function, which is y equals to 1 over 2 to the x power. So we're going to complete the table. If I plug in 0, 1 over 2 to the 0 power is 1. 1 over 2 to the first power is 1 over 2. 1 over 2 to the second power will be 1 over 2 square will be 1 over 4. 1 over 2 to the third power will be 1 over 8. If I plug in 1 over 2, so negative 1 power, since 1 over 2 will flip, so there will be 2 to the first power, which is 2. 1 over 2 to the negative 2 power will be 2 to the second power, which is 4. Negative third power will be 2 to the third power, which is 8. So if I plot all these points, I will get 0, 1, 1, half, 2, 4, 3 over 1 over 8. Notice that if I plug in 4 here, I would get 1 over 16, which is really close to 0, but never really 0. If I plug in 5, I will get 1 over 32, which is really tiny, but not 0. Negative 1, 2, negative 2, 4, negative 3, 8. So notice that this blue graph now decreases. It kind of approaches the x-axis, but it never quite touches it. Although the way I drew it, it touches it, but it actually never ever touches it. So in this case, again, the asymptote would be the same line, the x-axis, which we call y equals to 0 line. The domain, left and right, it goes on forever, so it's all real number. If you look at the range, again, y values are all the values above 0, so y will be greater than 0. Because this is decreasing, we call it exponential decay. I want to compare another function that is kind of similar to y equals to 2 to the x. Now we are talking about y equals to 3 times of 2 to the x. Or if you put parentheses around 2, that's just two different notation that represents same function. So these two equations are same thing. So it means from y equals to 2 to the x graph, which has this table, I'm just gonna, from that value, I'm just gonna multiply these values by 3. So if I multiply this by 3, we'll get 3 over 8, 3 over 4, 3 over 2, 3, 6, 12, 24. So if I plot these points, I will get 3, 6, 12 is off the limit. So negative 1, 3 over 2, which is 1.5. Negative 2, 3 over 4, which is around here. So notice that if you compare y equals to 3 times 2 to the x with y equals to 2 to the x, this green graph has been vertically stretched by 3 times, because we just multiply every point by 3. So 2 became 6, 1 became 3, and so on. So when you have this number right here, it stretches the graph vertically if the number is greater than 1. If that number is less than 1, then it's gonna shrink the graph. We're gonna talk more about that in the next chapter. To sum up, this is a basic form of the exponential function. We're gonna just assume that a is positive. So notice that if b, in our case, so in this case we don't really have a, that means a is 1, so you can just write that as 1 times 2 to the x. So when you don't have a number that is multiplied to the base, that means the number 1 is hidden there. So in this case, a is 1 and b is 2. So notice that if b is larger than 1, the function represents exponential growth. That means the graph goes up. If b is somewhere between 0 and 1, like in this case, b is 1/2, that means the function goes down, and we say that's exponential decay. In both cases, in either case, however, y-intercept is always gonna be this number a. So it's gonna be 0 comma a. Why is that? Because if you find the y, if you're trying to find the y-intercept, you always set x equals 0 and then find y. If I do that here, if I set that equals 0, y will be a times b to the 0 power. Well, we know that any number to the 0 power is 1. So that will be just a times 1, which is a. That's why we get y-intercept as a. So if you look back here to this function, we know that was our a, 3 was our a, 2 was our b. We get the y-intercept equal a, which is 3 right here. The domain of the function is always the real number in our cases. The range is y is greater than 0. The asymptote is the x-axis, which is y equals to 0 line. Okay, let's look at the example 1. Okay, what is the y-intercept of this function? Is it an exponential decay or growth? What are the domain, range, and asymptotes? Sketch its graph. Okay, so we know the basic form of the exponential function goes like that, and a, in this case our a is 2, b is 3. So to find the y-intercept, you just look for the a, which is 2. So we can say y-intercept is 0, 2. To find out if it's exponential growth or decay, we look at b. If b is greater than 1, in our case 3 is bigger than 1, then it's going to be the growth. If this number was less than 1, it's going to be the decay. Domain and range. Domain will be all real number, range would be y is greater than 0. The asymptote would be y is equal to 0, which is the x-axis. To sketch the graph, we plot the y-intercept, which is 2, and then we know it's gonna go up because it's a growth function. But we also know the asymptote would be the x-axis, so it should never touch, although it's gonna approach, it's never gonna touch that line. So it's gonna go up because that's the exponential growth, but it's never gonna touch the x-axis, although it's gonna approach to x-axis.